Mm-mm. Mm-mm. Yeah, mute. Mute.
Michelle,
Mute.
you're on mute.
Mute.
I did all that talking for no reason. That's good, actually. I was just there practicing, just babbling away. I was wondering why there was people talking in the background, but I thought, you know, my colleagues were just mocking me. Oh, okay. So let's start that from the top. Good afternoon, parents and carers. Welcome, Year 6 students. I know that you've had your creative clash lesson whereby you had that flare of art and science. And last week you had art. Today you're going to be having a science section or session. And I'm going to pass you over to one of our science teachers who is going to be most likely to be one of your teachers next year. Okay, so I'm going to be passing over to Mr. O'Riordan in a moment, and he has an amazing trick for you. Hope you can see him. Hi, sir.
Hi, everyone. Right, should I just get straight into it?
Yes,
Brilliant.
please.
Okay, I'm going to show you a quick demonstration of how rockets work. I'm going to just take out my headphones so you can hear me. I've dissolved just a little bit of alcohol, ethanol, inside of a bottle here. And I'm shaking it up just to get all those fumes nice and evaporated to make sure this is nice and full of ethanol gas. And I'm now going to put that in my ramp. Let's make sure that you've got a nice, good perspective of this.
Sir,
Yeah.
don't yet. Let me just try and get you so we can all and make you like the main screen.
Yes, if you could pin me so that you can see this nice and clear. Let me know when I'm ready to go, miss.
Will do. Okay, so you're all ready to go. So just to recap, you've got ethanol in your bottle.
Yep, I've put a little bit of ethanol inside of my 2-litre bottle, and I'm shaking it up to make sure that all of that alcohol evaporates. So it's now full of a gas, a very explosive gas. I'm going to put it in my ramp, and I'm going to ignite the bottom, and we're going to see what happens. Yes, thank you. Okay.
Ooh, wow. That's spectacular. Do you know what's going to happen, sir? As soon as they get today's QR code, they're going to be asking you to do that again. So I'm just saying. Wow, amazing stuff.
Thank
okay,
you,
let's go back
you.
to the PowerPoint. Okay, perfect. That worked perfectly well. I'm so impressed with myself. Okay, so today's session, the scientists have called it a rainbow. Is that correct, miss?
Correct.
Okay, so I can see lots of colouring pens. Is it going to be the same as Miss Tander's wow introduction 2 weeks ago, where she put all these different chemicals and had all these different rainbow colours? Is that what you scientists are going to be doing with us today?
Well, it's going to be similar. So basically, with those pens, different color pens, we are going to try and see if we can separate, for example, a black pen, and see how many colors that produces. So it's a similar effect, but it's just seeing a rainbow effect from a drop of paint or a drop of a pen on a piece of paper.
Okay, so Year 6, if you're at home and you've got any colouring pens, you might want to go and grab them. So all you would need is some colouring pens. I've got mine here because the scientist told me to have them ready. The colouring pens, any colours that you have. I love black or grey. Blacks are always normally quite good because you get a really nice, I'm not going to give it away. You need a piece of paper because obviously we are in a science lab. What I've done is I've got a special piece of paper and the scientists are going to be telling us what that piece of paper is called. But what you might need to do is grab on any old plain piece of paper. You would need some water. I've got my water in a very scientific bottle. And my water is distilled water as well. That just means it's water that has been boiled and evaporated and then condensed. So it's literally just water particles only. And then I've got what we call a beaker. So you can use a bowl at home instead of a beaker. Okay, so if you grab any of those equipment, and if we go into the next slide, and we can then have our Slido for today's session. So what is exactly what you've done before, and all you would have to do is scan. Okay, what would happen? I'm going to give the QR code because we've got our technicians presenting. I'm guessing our technician doesn't have the code, so I'm going to have to say today's code. So just like before, all you would do is go to Slido, and it will ask you for a code. The code is going to be #7608. So that's #7608. Once the scientists start the sessions, don't worry, what I'll do is I'll then go and set it up so I can then present. Okay. Okay, scientists, I'll now pass you over and you can start your session.
Mute.
Hello, year sixes, another week of fun, loving science, getting some practicals in. Even though we are out here in the virtual world, we are still making it happen. And when you get here in September, we will make it happen. Now, today's title, we're looking at, where are my slides, miss? Today's title, we are looking at chromatography. Now, the big question we have to answer at the end of this lesson, does your pen really have one color or several colors? So we need to decide at the end of the lesson what our pens have. And that topic is chromatography. And I have some questions just to tease your mind, just to see what we remember, and just to see how many words we can identify with that are important to the topic. All right, so my first do now question, and just like last week, we are going to be holding our answers in the chat. So you're putting in answers to questions 1, 2, and 3 before you send your answers in. And just like last week, it was so much easier when you had your name and your primary school. So your name, your primary school, and then your answers to the question. All right, so that when Miss is giving all the feedback, your name can be called and your primary school can be identified. All right, so let's get going. We are now ready for the question number 1. Now, how many words are you able to make from our topic? So our topic today is a long word, and we can find many smaller words hidden within. Chromatography. So again, you're finding as many as you can, and you're holding your answers. Do not press enter, because of course, somebody else can catch your answers before Miss starts to do her review. All right, so I'll give you a bit of time to put in those words. I'm seeing at least 5 words already. And I know my year 6s are able to find quite a bit of words. I'm even seeing 4-letter words.
5-letter words too.
Ah, well done. And once you have finished with the first question, go right ahead and answer the second one, but save all your answers so we make one send. So Miss will have your name, your primary school, and your answer. And this activity we do at the beginning of all our lessons. We do a do now task. So once you're in, you're going to be settling down and you're going to be answering some questions relating to your previous lesson, your prior knowledge, or just some settling questions. You should be on to number 2 by now. That's looking at the keywords that we have on the left. Can you identify by meaning? Could we go back to the do now slide, Miss? All right, so keep putting your answers into all 3 questions.
Sorry to interrupt, Miss. I was just trying to get the Slido so we can have the Slido poll. So now that we've got the poll, I'm just thinking for those of us that might not be technology current, I'm one of them, so no shame in my game. I thought because we're used to seeing the Slido, if I put the Slido, we can all sort of scan the code instead for those of us that are used to scanning the code.
Okay.
Is that okay?
Yes, Miss. Good idea.
It's just loading. There we go. So because I've had to open the Slido and open a new Slido, it's giving us a new code. So the new code is going to be #U736, or you can just scan that robotic symbol, so the QR code as we call it. With the old one that I gave earlier on, what would happen is I'm going to go back. So if you've left any comments on the old one, I'll be reading those out as well once the scientists have told me to go ahead and read out, feedback that we've gotten so far. That means I think I'll let you go back to your do now.
And so we got some extra minutes there. However, we were supposed to still be working on our do now task. So once you have found as many words, please move on. Now, question number 2, you would have seen the answer. You choose A, B, or C. And remember to put that in the chat and don't send it until you are told to do so. So sugar dissolves in water. This means that sugar dissolves in water. This means that sugar is A, soluble, B, insoluble, and C, solvent. So you are selecting based on either your prior knowledge, a good old guess, whatever it is, you're choosing one of those options to describe sugar as it dissolves in water. Your last question is true or false. So you're putting in A, B, and C as true or false for your answers. So once you have put in answers to all 3 questions, right, I'm certain we have had enough time now. So true or false, sand dissolves in water. You just put your letter A. Is it true? Or what do you think? Is it false? So go right ahead. You should have 1, 2, 3 answers, your name and your primary school. All right, as soon as you have all these things, go right ahead and submit your do now answers. All the best to year 6. Miss will be looking out for your responses. All right, so go ahead and submit.
Miss, I am super impressed. Like the attention to detail by our young year 6 students. Well, I should call you guys our future year 7 students. It's phenomenal. They follow the instructions to the T. The minute you said submit, because I was thinking, wait, nobody sent an answer. The minute you said submit, it all came flooding through.
Lovely. Lovely. So okay. Miss, you're going to go ahead and give us some of those feedback and the primary schools.
Okay, before I go ahead and read out the feedbacks, we've got a few greetings. So from Tate, says, hi everyone. Anupreet says, good afternoon. Anupreet from Bexleyheath Primary School, Miss. And then we've got a couple of anonymous. And then we've got a new print. I think she submitted an answer and maybe then realized that she's supposed to collect them. Okay, so here comes the first answer. I'll read the first two, Miss, just to save us time. First answer from Lucy from Belmont. So she's gone for mat, graph, tomatoes, tug, tag, match, pot, hat. So those were her key options for option 1. So how many words she could form from the word chromatography. And then her second answer, she said soluble. Her third, A was false, B was true, and then C was true. We've got anonymous from Burstwoods Primary School. At, rat, graph, mat, map, cat, rhymes. 2, soluble. 3, false, true, false. Oh, so that was Emily from Burstwood Primary School. And then we've got Terry Ann. 2, graph, chrome, got, mat, rap, map. B, insoluble. 3 was false, true, and true. And a couple of hellos, and then yeah, I think I'll stop there for now, Miss.
Okay, so I'm hearing words that I didn't even have on my list, Miss.
Like tomato.
Yes, tomato wasn't on my list. Well done, guys. So let us have a look. So could we
on your list? Because tomato has 2 T's and chromatography only has 1 T.
Oh. No wonder it wasn't on my list, because I'm like, really?
To be fair, it's a good one, and you can easily like slip that in.
Slip that in. And it actually got through to me. I was like, I didn't see tomato. All right, was that Emily? Make that correction, Emily. Well done, though. That was a close one. Because I'm like, oh. Okay, guys, let's go look at the answers and see what we did. Could I have a slide change? All right, so those are the list of words that we have or I came up with. Check your words. I heard graph, I heard mat, and I heard Miss Spitting Rhymes calling all those words together. And so you did well. And that big word contains loads of smaller words. And it's just a quick way to get familiar with the term chromatography. And remember, we are working with colors and we are going to find out exactly what this word means. We are going to find out the root origin of this word. And we are also going to answer whether your pen really has one color or several colors. So we are definitely going to be answering our exploration question. Now, question number 2. You were wondering about the solubility of, was it, I'm not seeing the questions. Now, we know that sugar dissolves in water. Yes, it is because it's soluble. And I heard the correct answers from all that Miss read out except for one person. So sugar is soluble. All right, well done. All right, so sand dissolves in water. Guys, this one is straightforward, and Miss did read the answer out as false, and all of you got this one correct, because we know that sand could not be dissolving in water and still be sand. No, we wouldn't have our beaches, would we? All right, now question part B, true or false? Most pen and marker inks are made by mixing different colors together. And I'm seeing true, and that is one thing that we are going to be exploring and ensuring that this is a fact. So I'll just leave it at true until we have done our checks for ourselves. Lastly, water is a solvent. Yeah, most things dissolve in it. True or false? And again, I heard this coming in from us, water is a solvent, most things dissolve in it. That's going to be true. Because think of your squash, think of your salt, sugar, all the things that you'll put in water, and it will form a solution, right? So we're going to learn more about those S words, your solute, your solvent, and your solution in a short while. So I am handing over now to Miss with the main part. And just like last week, we have loads to learn and loads of fun. See you guys later.
Hello, year sixes, soon to be year sevens. Welcome to another session. So as Miss rightly did, we did our do now. Now we are on chromatography, the main lesson. This is sort of like a think, pair, share. In a think, pair, share, you have maybe one or two or more questions where you think about the question, you pair up, and you share your thoughts or you share your answers. So basically, obviously, this is virtual. So what I would like you to do, there are 4 different questions, all interlinked with a challenge for the last one. What I would like you to do is think about the questions, and then we'll get you to share your thoughts. In class, you would pair up, and your pair would give an answer to a question. So I'll give you a few minutes. There's describe what would happen to the ink. How would you determine which pen contains one set of color, and so on, and down to the challenge? So this is what we know as a paper chromatography, which allows us to separate different substances based on their solubilities, and that means based on how quickly they dissolve, okay, in the water solution. But I'll give you a few minutes, have a think about those 4 questions, and Miss will share some of your answers. And don't press enter until I say enter. So I'll give you time to answer all 4, and then I'll say enter, and then Miss will read out what you're sharing to us. So as a guide, have a look at the picture. Okay, have a look at the pic, not the pens, just the picture, right? The picture with the beaker or the container. Have a look at that and just see what you can come up with based on the questions. So that picture is there just for a visual effect to help you ascertain what you think would happen. Right, you can all press your answers and the name of your school and also your name, and Miss will gather some of your thoughts and I can address certain things. Miss, are there any answers from our year 6s?
I knew I had to unmute my mic first, Miss. Okay, I didn't realize my camera was off as well. Right, I'm doing technical support today as well. That's why I'm a bit slower in terms of going back from one screen to another. But Miss, if I just go back to that long word chromatography, where the students had to come up with as many words as they could that's found within chromatography. So we just had Joseph from Upland. I didn't see his message. Basically, Joseph has come up with 2 that I must say, sorry, Miss, both of you didn't come up with. Right, now the second one, or Joseph's first one, I've heard of a crypto, but I'm not sure about cryptogram. So Joseph had, and I've checked every single letter in that word, and it is found in the word chromatography. So just so you all know, you might all want to write to Upland Primary School, Miss, and literally just talk about how brilliant the young people from Upland are. Obviously from Birthwood as well, and obviously from Belmont, of course. And then he's even got a scientific one that is actually related to the procedure, chromatography.
Chromatogram.
No, well, not that. because there'll be two M's in
M's,
chromatograph.
yes.
Pharmacy.
Ah,
Oh,
I
really?
know. Joseph, I'm not sure if you saw every teacher's face. Everybody was shocked because they didn't come up with that. And I think we're going to be linking that word pharmacy into today's learning as well. Okay. Right. So, Miss, you wanted me to go ahead and read answers?
Yes, please. Yes.
Okay. Whew, I shouldn't have been talking for that long. It's flooded.
Hmm.
So Emily from Burstwood says that she thinks that the ink will come out of the water and make a pattern in the water. Carrie Ann says that try it on paper and put it in water. You could tell by the ink. Thomas from Bedinwell says number 1, the ink will dissolve. Joseph says that the ink will separate out as it runs on the wet water. The colors, which are primary colors, should just have one color. Secondary colors would have more. And then we've got Anuprit says that the ink will dissolve in the water by watching the ink dissolve and what color it turns into. And then the last is the color it turns into when it dissolves. And then the last one I'm going to read out is Lucy from Belmont. I'm sorry, by the way, Anuprit is from Box Grove Primary School, Miss. Lucy from Belmont says that the dot will move up the paper, change color.
Right. Some of you got the general idea, especially Joseph and Lucy. So good points. The others, good points, but a little bit of misconception there. So some of you said the ink. So I was just writing it down and reading it. The ink would go into the water. Not necessarily so. So to be fair, that dot could be a black pen, it could be a brown pen. So literally, when we put that dot there, as Joseph said, that ink will separate into 1, 2, or 3 different colors. Okay, so the number of dots that separate determine whether it's a pure substance or it is a mixture. Okay, so this is something when you come in, you will be able to experiment and see for yourself. And also today, there are some videos that you'll be able to watch. You can try, and Miss will also perform one for you to actually see. So good points overall, but ideally, chromatography is used to separate good. That next slide tells you what what chromatography is made up of. So chroma, it comes from the Greek word which means color, and graphy means to write. So basically, what that is saying is we write or we put a dot using a pen, and we get a color from that pen. So using paper chromatography, you can use a filter paper, and one of the videos you can actually use coffee paper to actually do it. If we can go to the next slide, please. Right, so in chromatography, there are keywords that you will get to know. Some of you may already know this from prior knowledge or from just research or from asking a parent or somebody older than you or your teachers in school. So a solute is a solid that can dissolve in a solvent. Okay, so let's take for example, a lot of us, we use salt in our cooking. Mom puts a pinch of salt in our food, and what happens? It dissolves. So that salt is your solute. Okay, the solvent is usually water. Okay, so what this solid dissolves in. So mom's preparing a pot of soup. In that case, your solvent is mom's pot of soup. The solute is what mom has added that eventually dissolves. Or it could be you are having maybe a lime a hot lemon juice, lime juice. Your honey is your solute, which dissolves in your warm cup of lemon tea. Okay, your solution is then your salt or your sugar added to your tea, which now makes a solution. Okay, or you could use milk. Your milk could be your solute. I know it's not solid, but that could be your solute added to your water, which makes a solution. Right, the mobile phase is a phase which allows the ink to travel up the paper. So a good example of that, if we just go back to the slide before, sorry, yes, that one, that shows you you see that the water, that is your mobile phase because it's moving up the paper. Hence, what mobile means to move. So that water is moving. So if we go 2 slides forward, please. Thank you. Stationary phase is the phase that doesn't move. Stationary means you stand, you don't move. So it's the phase which does not move. An example of that is your filter paper or your chromatography paper. That doesn't move. The only thing that moves is your water, which runs onto your ink and causes the separation into different colors. Right, can we move to the next slide? Right, so this is a video presentation. Miss will do a practical live in front of you so you can actually see the process. So let's watch the video and capture 1 or 2 things we've learned from the definitions and the pictures we saw.
Okay, I'm so tempted to do a voiceover. However, I think I can just do mine really and truly. So if I'll just go ahead and stop the video. Now, you can actually get one of these online. I actually write anti-miss. If you just type in chromatography experiment, you'd have different versions that will come up. So feel free to do so. And luckily for me, because obviously Miss told me what it was that I was going to do it. And I thought, oh, I'm going to make my own. I've got one running at the moment, so I'm going to take you through that in a minute. So I'm going to just go ahead and stop the video. Right, in the meantime, in the chat window, can you tell me what is the difference between the mobile phase and the stationary phase? So in your in the chat window, so using the QR code, could you type in the difference between a mobile phase and a stationary phase? Don't submit your answers as of yet, please. Okay, so you can submit your answer. Now, when we do this in class, I always say to young people, whatever you do, do not move your beaker around. So for those of you that said, oh, the ink will go in the water, if you move your beaker around, that's exactly what happens. So here's my first chromatogram. I'll demonstrate to you in a minute exactly what I did to get that line and everything else. And I'll work backwards. So you can clearly see that whatever the substance that I've used, so in this case, it's a black marker, this marker isn't soluble to water. So here goes that keyword. The ink, my board pen, is not soluble to water. Why is that? Okay. However, so this is brown from my coloring pen, and you can see that that brown has separated into different colors. So that means that this marker is soluble to water. Okay. If we go back and we think about those keywords, so soluble means it is going to dissolve. Insoluble means it doesn't dissolve. Now, I'll come back and I'll just go over and read some of your comments in terms of, oh, you can submit your answers for, okay, they're there already. So mobile phase makes the ink go up the paper, and the stationary phase is the opposite. So that's Anuprit. And Joseph says that the difference between the mobile phase and the stationary phase is the mobile phase is when the ink is traveling, and the stationary phase is when the ink has stopped. Okay, so really good answers there, guys. If we come back to mine, the paper, so for example, the paper, my piece of paper is called a chromatography paper, okay? So that means that this paper is able to separate colors if the color actually has a mixture of different colors. Like Joseph said, or somebody said earlier on, if it is a primary color, you're not going to have any separation because a primary color only contains one color. If it's a secondary color, you're going to have different separation. So you can start to see in the case of my black ink, the reason why I've only just got just that black, a little bit of it has gone off the paper. You can't see that yet. You see like a little black line from that dot. It doesn't mean that black is a primary color. It just means that in this case, the black hasn't dissolved. Now, so here's my chromatography paper, and that's the stationary phase. Now, this piece of apparatus, we call it a beaker because we use a beaker a lot in science labs, and we use them as a container to hold our chemical reactions. We don't use it for measurement. For measuring, we use what we call a measuring cylinder. So now I measured about, say, 10 centimeter cubes of water, and I pour that into my beaker. Now, if you remember, you saw a line in pencil. So there's a line that I drew in pencil. Start thinking as to why I've drawn that in pencil and not pen. So start thinking about that. And then all I did was I now took, so I'll just do that as we speak, if I can find my pencil. So here goes my chromatography paper. And I'm going to measure about, say, 1 centimeter from the bottom. I would normally advise you do about, say, 2. However, because my chromatography paper is quite short, if I did 2, my color is not going to have enough space to spread up that paper. Okay, so there goes my line in pencil. Remember, you're wondering or you're thinking, why is Miss drawn that using a pencil and not pen? And then all I did was I'm going to use purple this time around. I took my purple coloring and I just placed a dot in the center. I always put a dot and then move away because if I just held the dot on the paper, it's going to soak it up. So for example, now for those of you that didn't have paper, I didn't have a big paper, so I found tissue instead. So if I put a dot and then I hold it, it spreads quite quickly, and I don't want that. So it's a dap and pull away, a dap, or the same spot actually, and then you pull away. Okay, so I put a couple of dots on my line. Do I need to draw a line? Why not just take a piece of paper and actually place the color? Now, in most cases, as scientists, we're never just going to have one color or one sample. Okay, so in this case, I want both samples to be at the same point, almost like a race. So I'm giving everybody a fair chance. And that's exactly what was being shown in that video. She drew her line and placed her dots. My last one, I think I was talking and I held it, so you can see it spread a bit more than I wanted to spread. Now, in all fairness, what you really want to do is you want to keep those as far away from each other as you can, and then as far away from the edges as possible, because you don't want it to end up in the water. You want it to stay on the paper. Now, the paper is a stationary phase. That means the paper doesn't move. However, the water is going to be the mobile phase, because the water is going to go up the chromatography paper. And as the water travels up the paper, it's going to do what? Because water is a solvent, like Miss said earlier on, is going to dissolve those samples and then carry the samples up the paper. Now, there's a bit of a science behind it, and I'll keep it as simple as I can, just for, not to make it a bit too rocket science, so to speak. The colors that bind better with the paper are left behind, okay? The colors that bind better with the water are carried up the paper. So if you come and you're looking at the one that I did earlier on, that was brown. So it was this brown marker, yeah? You can start to see that orangey color at the bottom binded better with the paper than it did with the water. Whereas the blue was more soluble. So the blue binded better with water. So that's just the science behind that. Okay, so I'm going to place that. I'm being very naughty because you don't move the beaker. You don't want the water splashing everywhere. So the water literally just touches the bottom of the paper and then eventually goes up. So I'm going to just leave that standing and then let Miss carry on with her lesson, and then I'll come back and show you what that looks like. If you're actually doing this at home, please don't forget to take pictures and send us what you have. So on my tissue paper, I put different colorings on there. So all I'm going to do is I'm going to add some water at any point on that piece of tissue. And as the water travels, it should spread across my paper. And I'll be showing you that as well. So you can actually do this at home also. Okay, so I'm going to just leave that to stand still. And I'll pass it over back to Miss. Miss, you're going to have to give me a few seconds because I have to go back to the presentation as well. Over to you, Miss.
Thank you, Miss. Thank you. Right, so whilst Miss is sorting the slides out, that was a really lovely practical demo of how chromatography can be done at home. Obviously, we're using a little bit more scientific equipment. So she showed the beaker, the chromatogram, a few different color pens, and distilled water. Okay, so those are it's literally quite easy for you to do at home. In the labs, you'll be able to see it in better. Right, this slide shows you what Miss was trying to say. So this is literally a result of what you would get during a chromatography experiment. So we can see we put a brown dot, we put red, blue, and yellow, and we can clearly see the pencil line. Okay, so that pencil line is drawn so that we're using pencil so that it doesn't get moved up by the mobile phase. If we use the pen, then that pen will contribute to the colors being separated, hence the use of a pencil. So we can see using the brown ink, 3 different colors popped out or separated. Red only gave red, blue only gave blue, and yellow, which means the red, blue, and yellow are pure substances. The brown ink isn't pure. Why? Because we have 3 different colors that separated just from that brown ink. So this tells you which one that we can determine a pure substance from a mixture. And we can also use this process in the medical field, where they're able to separate out different substances to make sure that medication or drug has a pure substance and what has a mixture. So there's so many applications of chromatography in everyday life. A good one is in medicine. A good one is in the school to show students what chromatography is about. And even, I said medicine, even in analytical chemistry, we also use this to separate mixtures to obtain pure substances. So can we go to the next slide, please? Oh, this just shows a quick, I think it's a 2-minute clip of how you can actually do it at home with common household equipment. So that's a coffee filter paper. She's drawn a circle using a dark color, could be brown. She's folded it up. So this is something you can easily do. Place it in this is a glass. We would use a beaker in the labs and watch what happens. So you've left that for a few minutes, and over time, different colors get separated out just from that brown circle. And I'm sure for those who are creative, you can use these to make different arts and crafts. Yeah. And that is just from a little science experiment. Right, so that is, I'm not sure if Miss will be able to show you what she was able to do.
What I achieved? Yeah, I was being a very bad scientist. That's what you never move the beaker, because you can actually see that my collars are literally starting to run into each other, and that's not what I wanted. Can you guess what marker I've used? So what color ink was used at this, for this, the middle one, and then the one on my right? Any ideas?
Pop your answers and send to Miss so she can read them out.
And I'll reading those out in a minute. I'll have it to keep running. Now, if we go back and think about what Miss said, so in terms of analyzing, so we don't just do this in science for the fun of it. I can start to see the different colors that are found in the different ink. So, for example, I can see that all three of them have got a couple of colors, in common. So you can see they've all got blue. And look at the area where blue is being separated. It's around the same sort of range. When you get to, say, year 10 and year 11, I know you're thinking that's such a long way to go. It does come really quick, but we get to do what we call calculating arrow values, okay? So I would then calculate the distance that blue color has moved, and then divide it by the distance that's moved by the solvent to give me a value. And you can start to see that the blues all have a similar arrows value, meaning that the blue samples are identical. Clearly, all my three colors are a mixture, because like Miss said, if it was a pure substance, you would only get one separation, wouldn't you? Because I have a mixture, you've got different colors. Okay, so I think it's my turn to go off and then go and read some of the comments that have come through. So I still got lots of questions about the mobile phase and the stationary phase. So I think we draw in pencil, not in pen, because it was drawn in pen. If it was drawn in pen, it will also run. So that's a really good answer. That came from Joseph from Upland. That's very true. Ink, like Miss said, is also soluble, so it would interfere with your results. Great suggestion. Joseph said you can actually do this with using Skittles, M&Ms. So there are lots of videos on YouTube where all these different sweets and different household, everyday household apparatus or equipment have been used to investigate chromatography. Your food and your drinks contains a lot of colors. So color, we call them additives in science, to give it that color, to make it attractive, and so on and so forth. Now, what a food analyst would do is they test those colors to make sure that there are no contraband, there are no illegal colors in your food and your drink. The setting colors or additives end up making people act funny or very hyperactive, and some of those additives are illegal. So it's a really, really good suggestion. They're using Skittles. Lucy said brown. So I'm guessing we're going back to when I said, what color do you think, what color marker was this or this or this? So yeah, so that one there was my brown. And that's it from chat so far, Miss.
Right. Thank you, everyone. Again, Joseph, you are there with the suggestions. Well done. By the way, can I just ask, Joseph, what is your best subject? Because it seems there's a trend here. You seem to like science, but I might be wrong. What's your best subject? Do let us know so that we are prepared for when you come. We can spot Joseph a mile off with the science badge on, saying I am ready for science. But yeah, so literally that is chromatography in a nutshell. It's all about separating colors to identify if they're pure or if they're a mixture. Okay. So I'll hand back over to Miss, who will do the final bits of this lesson.
Okay, before we pass over to Miss, sorry to just interject there, Miss. Can we have everybody just writing at the moment, what do you think your favorite subject is? So is it PE? Is it science? Is it art? Is it English? So we can then get everybody, you know, we can read everybody else's as well as Joseph. Over to you, Miss Orridge, sorry. You're mute.
Sorry, Miss. Sorry, guys. A lovely bit of information there. It would be good to know. We are biased in science, and we would really want to see our scientists that are coming in. And I am betting on science for Joseph. No pressure, Joseph. Now, let's see. Assessment for learning. Now, this is also a part of your lessons once you get here. You're taught the topic, you have discussed it, you have done practicals, or you have done videos. So we have done a combination of learning methods today. You have even seen a demonstration. And the assessment now is to test how much we really remember, how much we can relate to. So let's go right ahead with our questions. Now, true or false? A pen must be used to draw the line at the bottom of the paper. True or false? A pen must be used to draw the line at the bottom of the paper. Go right ahead and submit your answers. Let Miss have something to do. Miss, you're looking for the first person submitting. You're looking for the most popular answer. True or false? Which of them?
Sorry, Miss Wallace on number one. I've got people who've actually answered all of them already. So, I'm gonna go for the first. So yes, the first one we've got Anuprit with false.
Is there anybody who has taken it a notch like last lesson, Miss, and know that the why is there? Did anybody give the why? Why is it a false? Why can't we use a pen?
No, but I've just got people that have actually answered all 4 questions, Miss.
Oh, they know it. we are in for it.
This is so impressive.
Definitely, we are not going to be using a pen. That's false. And we have seen it so many times with Miss explaining, showing us her demonstration, and Miss telling us when she was giving the main bit. Question number 2. The water in the beaker must sit below the ink dot. The water in the beaker must sit below the ink dot. Is that the answers are should be coming up, Miss? For question 1, right? So just in case, Miss, your answer now, you have all the answers. So can you see question number 2 being the popular? What's the popular answer?
Okay, so Anuprit actually wrote in a reason as to why number 1 was false, because the pen will dissolve too, so we use the pencil. So for question 2, we've got false. We have got true. Oh, a mixture. 4 false. We have true. So we've got 1, 2. Yeah, there's lots to count. I'm not even going to try to.
Okay.
I think it's an even split, Miss. It's 50-50.
Okay, so the water in the beaker must sit below the ink dot. And we are going with the half that says true, because if the water is not below the beaker, we have gone through this, you'd have seen that we would have messed up our practical. If the water is above, then that ink is going to be going directly into the water, not climbing up the sheet with the mobile phase at all. Yes, and see, Miss has been
So I'm trying to demonstrate what
demonstrating.
happens if the ink is below. So I've put my ink
Below, yes.
below, and you can
It's
actually
spread.
see it's moving in both directions, by the way.
Uh-huh.
Yeah.
So right away, we know that our results would not be very good. All right, the third one. Only insoluble substances will move up the paper. Who remembers what Miss said about insoluble? True or false? Only insoluble substances will move up the paper. Again, Miss, check your answers to see.
Okay, so I have got false, false, one true, and I'm waiting for the rest to come in. I'll just scroll up just in case I've missed it. Oh, I should scroll up the ones that I put it onto the 4 to start
All
with. So
of it, yes.
Yeah, I've got false. So that was question 3. So I've got false, false, lots of false, Miss. So
Okay, well done. So majority of us have grasped and know that definitely the answer is false, because if it is insoluble, for example, like sand, it will not be dissolving. So we would not even be using this method when it comes on to separating. The last question we have here is chromatography can be used to identify dyes in foods that may cause allergies. Now, this question is our final question. Miss, check. So chromatography can be used to identify dyes in food that may cause allergies. True or false?
okay, so true, true, false, false, true. I even have an answer to an exploration question as well, Miss.
Even.
Yeah, so lots of truths there, Miss. There's definitely more truths than there are false.
And it is true. So well done, guys. It is true. And just like we mentioned, yes, thank you, Miss. Just like we mentioned, we said chromatography can identify the allergens. So anything you're allergic to, you can see through this method. It identifies anything that is not allowed in our foods based on our allergies. Now, EQ question, our exploration question, like any good lesson at the end, we should be able to answer the question that we got at the beginning. Miss, you already have answers.
I have one person. So one
Okay.
person has sent in the answer already. So when they sent in the AFL question, they sent it in already.
Just clean it up, clean up everything. Okay. Does your pen really have one color or several colors? I'm positive we all can answer that question at the end of this lesson. We saw it in so many ways. We saw the brown ink going up the paper, and I'm sure we saw several colors, Miss. Yes, well done. So right away, we know the answer to our exploration question to today's lesson. A short lesson, a fun lesson, a lesson that has all the aspects of what you can expect here in September. Your do now, your main bits, your exploration question, and your assessment for learning at the end. So we all now know that our pens, majority of our pens, are going to be a mixture of different colors. And if there is one color, it means that the ink in our pen is a pure or a primary color. Righty then, over to you, Miss.
So my green ink has washed into the beaker.
Okay.
Yeah, so that is why you always have to make sure that your sample sits above the water. Excellent. Okay, so just going back to the chat window, it has been busy in the chat window. We had, in regard to, we asked, yes, students to tell us what their favorite were. Lucy said maths.
Okay.
Joseph, so Miss Adejimo, you were right. So Joseph is art, science, and coding. We've got Safi says hers is art and PE.
Mhm.
It's all kind of like mingled with other things now. Josephine said English was her favorite. And then the rest, because I've transferred all the comments into a different window, it's all kind of mixed up now. But those are the ones that, so Thomas says history is his favorite. Sorry if you sent and I haven't called your name. It's just I've transferred it over, so it's somewhere that's saved. And now it's all mixed up. Thank you so much, scientists. Right, now, just before we end today's session, if you want to see Sir's rocket launch again, can I get a high five in the chat? So the high five is rocket launch 5.
High five.
Launch 5. But who should we ask for before we actually get Sir to demonstrate? We don't want him wasting our ethanol, do we? Right, so I hope you're setting up because it's starting to all come through. Yeah, I think Sir's getting himself ready. Right, while Sir's just getting himself ready, just to let you know what's coming up. So this is our last session because obviously we couldn't do Thursday because Thursday is a half day for most schools. Some of you probably might not even be in school on Thursday. So when we come back after Easter, we'll come back to our Thursday weekly sessions. You're going to have live sessions as well as pre-recorded sessions as well. Your future teachers have been busy literally preparing some impactful lessons just to show you what a typical English might be like, a typical history lesson, and so on and so forth. So you're looking forward to those when we come back, as well as you've got 2 more art and science lessons as well. Now, everything that we do is always going to be on YouTube. So do feel free, or make sure, if you can't watch it on the day, don't worry so much about it. Just make sure at some point you log on, go on YouTube, and then you can actually watch whatever it is that you've missed out. Do complete the checkouts, because the checkouts tell us what school you've come from, and then we can literally give a shout out to your primary school and tell them how fantastic you have been. So it looks like you're ready.
Yes, I am, absolutely. Can we add
Okay.
Miss Atajumo back in? I don't want her to miss this.
Okay, let me just go ahead and then go back to my stream and then get Miss to come back in. Ooh, I almost removed you, sir.
Oh, no. Right, okay, so once again, I have added a few dropfuls of, it's very bright, there it is, ethanol. Right, there we are, ethanol into my 2-litre bottle, and I'm shaking it up to get that nice and dissolved. So this bottle is now full of fumes, and I can organize this once again, just so you guys can really see it take off. Go just shaking it up, just to get that all nice and evaporated. Put in the ramp. Right, let's get ready to ignite it. Okay, are we all ready? Don't look away, don't blink.
Wow.
Oh. Got some ashes flying around. Right. Thank you very much, everyone.
There's so much physics in that demonstration, so I love it. And I'm thinking in regards to, it went straight in a straight line to start with, and then it curved. So much physics matter in there.
It is.
Okay. Thank you all. Thank you, Year 6. Parents and carers, if you've been watching as well, thank you for bringing the young people to our session once again. It's been a fantastic 3 lessons for us, and it's been a pleasure having all you young people take part. Make sure you go back and you let your friends know so they do not miss out our coming sessions when we come back after Easter. Okay, so if you have any questions, please do not hesitate to send me an email. Remember, it's ishallow@bexleyheathacademy.org. If you've got questions you want answers to, feel free to do so as well. Don't be shy, introduce yourself by email as well. If you want any work today and Mine didn't go so well. I feel like I sneezed on it. If you've got better than mine, or if you've got anything that you've done today, take a picture and send it in so we can give you an even bigger shout out. For those who took part in our first session on the Creative Clash, and you drew your dandelions and send those to us, what we've done is we've made a beautiful collage and we have put that on our Twitter page. If it hasn't gone up yet, it will be going up. So I know that I saw the email about it going on Twitter on Friday. So thank you so much once again for joining. I feel like I've left something out. Other than saying
Mr.
goodbye.
Homework.
Yes, the checkout. Yes, that's going to be on the site. Oh, that's what I've left out. We have got an amazing Easter activity lined up. So do ask your parents to look forward to the emails that we're going to send to them. And the emails are going to contain how to access the Easter activities, or you can just go on our website under transition. We have got not just lessons, we've got not just quizzes, we've actually got tours that you can take part in also. So I know you can't just get up and, you know, get on the train and go to London and go to natural history. However, we can actually do that virtually, and we're going to make sure you still have those experiences as best as you can. So do make sure you check out our Easter activities. Right, so for myself and the rest of the science team, thank you so much for joining us in today's session, and we look forward to seeing you. Have a good and safe Easter. Bye for now.